Hello friends, and welcome to YouTube channel on Engineering Mathematics by Dr. Navneet. In this video lecture we are going to discuss how to find the value of particular integral when the right hand side of linear equation is a trigonometric function. That means right hand side may be sine of ax or cos of ax. Then this is our type number 2. So before going to this type number 2, let's discuss the basic results which are useful to learn this type number 2. So trigonometric results which are required to learn this type number 2 are 2 times cos a cos b equal to cos of a plus b plus cos of a minus b. Then 2 times sin a sin b is equal to cos of a minus b minus cos of a plus b. 2 times sin a cos b equal to sin of a plus b plus sin a minus b. And 2 times cos a cos b equal to sin a plus b minus sin of a minus b. So along with this standard result, we also require the result of sin square x and cos square x. Sin square x is equal to 1 minus cos of 2x upon 2 and cos square x equal to 1 plus cos of 2x upon 2. So these are the basic results which are required to convert the equation in terms of standard form. So now before going to the form, let's try to understand the meaning of term 1 upon d into x. 1 upon d into x is that function of x which when operated by d gives the value of x. So here the meaning of term d is derivative with respect to x. So therefore 1 upon d x equal to integration of x dx. So this formula is very much useful for solving the example which is based on type number 2. So that means this formula is applicable when 1 upon single d term is present in the denominator. Then take the integration of x dx. Once again I will repeat the formula. So 1 upon d into x equal to integration of x dx, and this formula when we have to apply the question. So answer to this question is that this formula is applicable when we get single d term in the denominator. So now to understand this formula, let's take the example. So 1 upon d into e raised to 2x equal to integration of e raised to 2x dx. So we know that integration of e raised to x is e raised to x. So e raised to 2x upon derivative of 2x is 2. Similarly 1 upon d into sin of 3x equal to integration of sin of 3x dx. So which is equal to integration of sin is minus cos. So minus cos of 3x upon derivative of 3x is 3. Similarly 1 upon d into x square equal to integration x raised to 4. 1 upon d into x raised to 4. So integration of x raised to 4 dx is x5 upon 5. So 1 upon d into sec square x equal to integration of sec square x, and we know that integration of sec square x is tan x. So this is the meaning of term 1 upon d into x, and this is very much useful for solving the example based on type number 2. So once again this formula is applicable when single d term is present in the denominator. So now let's try to understand type number 2. So how to solve the linear differential equation with the example based on type number 2. So once again this formula is applicable when single d term is present in the denominator. So now let's try to understand type number 2. So how to solve the linear differential equation with constant coefficient when the value of capital X, that means right hand side term, is trigonometric function which is either sine of ax or cos of ax. Then in this case or in this type the particular integral is given by 1 upon f of d square sine or cos ax equal to f of minus a square into sine or cos ax. So this is happen if the value of f of minus a square is not equal to 0. So here the meaning of term f of minus a square is that replace d square by a square, and after replacing d square by a square attach separate minus sign to a square term. So that is the meaning of term. So this formula in simple language says that replace d square by a square with minus sign. Again, when we try to solve the example based on this type, so question may get arise in your mind that how long we have to solve the example. So answer to this question is that if the denominator reduces to constant term, then we get the value of a particular integral of the linear equation. Again, if we replace d square by minus a square, then question may get arise that what about d cube term or d raised to 4 or d raised to 5 term. So in this case, so we can write d cube term as d square into d. So we can only replace d square by minus a square and so on, so that we get d cube is equal to d square d, and we can replace d square by minus a square. So answer is minus a square d. If we try to simplify d raised to 4, then we get this as d square its square. So if we replace d square by a square minus sign its square, so we get final answer as a raised to 4. So in this way we can replace d square by a square with minus sign, but do not, when we replace d square by a square with minus sign, it's do not means that replace d by root of minus a square. So this is the wrong method. So above formula, so the formula type number 2 for finding the value of particular integral. So if we write in particular, then value of particular integral is 1 upon f of d square sine of ax equal to f of minus a square sine of ax, and this is possible only when the value of denominator term f of a square with minus sign is not equal to 0. Similarly, 1 upon f of d square cos of ax equal to 1 upon f of a square with minus sign cos of ax. Again, this is possible only when the value of denominator is non-zero. So now here, before going to the actual example, let's try to understand the meaning of d square and when we replace d square by minus a square. So if we try to replace d square by a square with minus sign, then we get three possibilities. So these three possibilities are, so first possibility is getting constant term in the denominator. That means when we replace d square by a square with minus sign, then it may possible that we get constant term in the denominator. So here is the example. So 1 upon d square plus 9 into sine of 2x. So if we replace d square by minus a square, so value of a is 2. Then if we replace d square by 2 square minus sine, then final answer is 1 upon 5. So that means 1 upon 5 into sine of 2x. That means when we replace d square by a square, we get constant term in the denominator and we get the final value of particular integral, and that is the end of example. But it may possible that we may get the 0 term in the denominator, so which is the second possibility, getting 0 term in the denominator. So here again example is 1 upon d square plus 4 into sine of 2x. So sine of ax, that means value of a is 2. So if we replace d square by a square, then we get this as 2 square with minus sign plus 4 into sine of 2x. So that means minus 4 and plus 4, we get the value of denominator as 0. So whenever we get denominator value as 0 in this case, then simple method for solving this type of example is that attach x on numerator and take the derivative of denominator with respect to d. So here attach x on numerator is x, so derivative of d square is 2d into sine of 2x. So now again question arises that, so according to the formula for finding the particular integral, we for sine of ax or cos of ax, we are replacing d square by a square with minus sign, and here we get only single t term in the denominator. So in this case, apply the operator 1 upon d into x, which is equal to integration of x dx term. So to remove the d term, so we can write this as x upon 2 into integration of sine of 2x, which is minus cos of 2x upon 2. So finally we get this as minus x upon 4 into cos of 2x. That means second term is that when we get 0 term in the denominator, so in this case attach x on numerator and take the derivative of denominator with respect to x. So this is the second possibility. Whereas third possibility is that, so when we try to replace d square by a square with minus sign, so it may possible that we get a single d plus a term or d minus a term in the denominator. So in this case we have to rationalize the term so that we get d square in the denominator. So now again example is 1 upon d square plus 3d plus 2 into sine of 2x. So according to the particular integral formula type number 2, so we have to replace d square by a square with minus sign. So value of a is 2 because sine of ax is equal to sine of 2x, so value of a is 2. So if we replace d square by minus a square, then minus 2 square plus 3d plus 2 sine of 2x. So if we simplify this equation, then we get denominator term as 3d minus 2. And we cannot remove the term d according to the type number 2, because type number 2 mentioned that replace d square by a square with minus sign, and here we get the single d term. So to get d square term in the denominator, so let's rationalize the term. So rationalize the term means, so in denominator we get the value as 3d minus 2, so multiply and divide by 3d plus 2 and 3d multiply and divide by 3d plus 2. So we get answer as 3d plus 2 upon denominator 3d minus 2 and 3d plus 2 into sine of 2x. So numerator as it is 3d plus 2. So don't do the actual calculation for the denominator. So instead of doing the actual calculation of denominator, use the formula a minus b and a plus b. So its answer is a square minus b square. So if we apply this formula, then we get the value of denominator as 9d square minus 4. So again here if we observe that after rationalizing the term, we get d square term in the denominator. So now we can apply the formula number or type number 2 for replacing d square by minus a square. So after replacing d square by minus a square, we get the value of denominator as minus 40. So again one d term is available in the numerator. So take the term sine of 2x in numerator. So we get 3 into d sine of 2x. So d means derivative with respect to x. So derivative of sine of 2x is 2 times cos of 2x. So 3 to the 6. So we get the value as 6 times cos of 2x, plus second term is 2 into sine of 2x. So we can directly write the value of second term as 2 into sine of 2x upon denominator minus 40 as it is. So in simple word, when we replace d square by minus a square, we get 3 possibilities. So first possibility is we may get constant term in the denominator, no issue. Then second possibility is that we may get 0 term in the denominator. Whenever we get 0 term in the denominator, attach x on numerator and take the derivative of denominator with respect to d. And the third possibility is that we may get single d term in the denominator as d minus a or d plus a. In this case, rationalize the term. That means multiply and divide by some d plus a or d minus a factor. So now to understand this type number 2, let's take the first simple example. So example is solve the linear differential equation d square minus 5d plus 6 into y equal to sine of 3x. So we know that linear differential equation with constant coefficient has 2 type of solution. First is called as complementary function and second is called as particular integral. That means complete solution is the sum of complementary function and particular integral. So if we try to first find the value of complementary function, again complementary function is obtained by solving the auxiliary equation. So here the value of auxiliary equation is d square minus 5d plus 6 equal to 0. So this is quadratic equation. So if we solve according to the quadratic equation method, we get the root as d equal to 2 and 3. Our second method is that, so find a number whose product is 6 and addition is minus 5. So these numbers are minus 2 and minus 3. So we can split middle term minus 5d as minus 2d and minus 3d. So we get root as 2 and 3. So these roots 2 and 3 are real and non-repeated. So according to the standard formula for finding the value of complementary function, so here the value of complementary function is c1 e raised to 2x plus c2 e raised to 3x. So this is the first solution, which is called as complementary function of the linear equation. Let's denote this by a. Now next, find out the value of particular integral. So whenever we find the value of particular integral of any equation, so first write the right hand side value of linear differential equation with constant coefficient, which is denoted by x. So here the value of x, that means capital X, is equal to sine of 3x. So if we compare this value with the standard formula or standard type, x is equal to sine of ax, then the value of a is 3. So then according to the type 2 formula for finding the value of particular integral, so particular integral is 1 upon f of d square sine of ax equal to f of a square minus sine into sine of ax. If we apply this formula, then we get the value of f of d as d square minus 5d plus 6 into sine of 3x. So according to this formula, it is always possible for us only to replace d square by a square with minus sign. So if we replace d square with a square with minus sign, then we get the value as 3 square, which is 9, and minus sign minus 5d plus 6 into sine of 3x. So if we simplify the denominator term, then we get the denominator term as minus 5d minus 3 into sine of 3x. So for our simplicity and to avoid the complications in calculation, take minus sign as common, then we get value as minus 1 upon 5d plus 3 into sine of 3x. So now again here question arises that, so how to apply the formula, because according to the formula, so our it is always possible for us only to replace d square by a square with minus sign, but here we get single d term in the denominator, that means 5d plus 3. So we get this this equation in the form of d plus a form. So now we require d square term, and here we get single d term. So to get d square in the denominator, so that we can apply the standard formula for particular integral, so let's rationalize this term. Rationalize this term means what? So in denominator we got the term 5d plus 3, so multiply and divide by 5d minus 3, so that we can rationalize this term, and after rationalizing this term we get d square term in the denominator. So numerator value as it is 5d minus 3, minus sign is common, and again apply the formula a plus b and a minus b, which is equal to a square minus b square. Then directly write down the value of denominator without taking any product. So after formula we get the value of denominator as 25d square minus 9 into sine of 3x. So this is happened because of the rationalizing the term, so that we get d square term in the denominator. So now minus in numerator 5d minus 3 as it is. So again replace d square by minus a square, so we get value as minus 9. So if we simplify the denominator term once again, then we get the value of denominator as minus 234. So minus minus become plus. So here d term is removed from the denominator, but single d term is available in the numerator. So now to remove this d term from numerator, so now take sine of 3x to the inner side of numerator. So 1 upon 234 as it is in denominator. So 5 into d sine of 3x, that means d stand for derivative with respect to x. So derivative of sine of 3x is 3 times cos of 3x minus 3 into sine of 3x as it is. So once again if we simplify this term, after simplifying this term or dividing by 3, we get the final answer for particular integral as 5 cos of 3x minus sine of 3x upon 78. So this is the value of particular integral. So in this way we find the value of complementary function and particular integral. So from equation A and B, so B equation is related to the particular integral. So from this equation we get the complete solution, which is the sum of complementary function and particular integral. So y is equal to c1 e raised to 2x plus c2 e raised to 3x plus 1 upon 78 5 times cos of 3x minus sine of 3x. So this is the first example for solving the linear differential equation when right hand side of linear equation is either sine of ax or cos of ax, that means trigonometric function. So now to understand this method clearly, take the second example. So now here a linear differential equation is d cube minus 3d square plus 9d minus 27 into y equal to cos of 3x. So this is cubic equation. So first find out the value of complementary function and then find the value of particular integral. So here auxiliary equation is d cube minus 3d square plus 9d minus 27 equal to 0. So if we apply the concept of synthetic division, then we can easily get the root of this equation as d equal to 3 plus minus 3i. That means we get the complex root. So now according to the standard formula for complementary function for complex root, so here the value of complementary function is c1 e raised to 3x plus c2 cos of 3x plus c3 sine of 3x. So this is the first equation which is called as complementary function, denoted by equation A. So then for finding the value of particular integral, let's write down the value of right hand side term, so which is denoted by capital X. So here the value of capital X is cos of 3x. So if we compare this value with the type capital X is equal to cos of ax, then the value of a is 3. So then according to the standard formula, which is type number 2, for finding the value of particular integral, replace d square by a square with minus sign. So we can solve this example with the help of two different methods. So now let's discuss the first method. So now here in denominator we get the value as d cube minus 3d square plus 9d minus 27. So according to the formula, we are replacing d square by a square with minus sign, and we get here first term as d cube. So we cannot replace d cube, so that's why. So use the factorization concept which is available in complementary function. So we can write d cube minus 3d square plus 9d minus 27 equal to 0 as d minus 3 and d square plus 9. So we take the factor of this term because according to the type number 2, we are only able to replace d square by a square with minus sign, and here we get the value of d square. So now again second term is d square plus 9, but first term is d minus 3. So now to get d square in the first term, so rationalize this term. So why we are rationalizing this term? Because first term is d minus 3, and to get d square term in the first bracket of denominator, so let's multiply and divide by d plus 3. So after multiplying and dividing by d plus 3, we get equation as 1 upon d minus 3 and d plus 3, that means d square plus a square, d square minus 9 into d square plus 9, and numerator is d plus 3 into cos of 3x. So now according to the formula, replace d square by a square with minus sign. So if we apply this concept, that means if we apply type number 2, then in first bracket we can replace d square by a square with minus sign, then answer is minus 9 into minus 9, which is non-zero, that means minus 18 we are getting. But if we try to replace d square by a square in second bracket, that means if we replace d square by 3 square, which is minus 9, then in second bracket we get answer as 0. So to avoid the denominator value as 0, so keep the second bracket as it is. So if we simplify in the next step, we get answer as 1 upon minus 80 into d square plus 9 then first multiply d plus 3 into cos of 3x, we get answer as derivative of cos of 3x is minus 3 sin of 3x plus 3 times cos of 3x as it is. So now, so here we keep the term 1 upon d square plus 9 as it is, because if in this term if we replace d square by a square with minus sign, then we get the answer as 0. So to avoid the 0 in the denominator, we keep that term as it is. Now once again, if we simplify numerator and denominator, then we get the value as 1 upon 6 into d square plus 9 and in bracket sin of 3x minus cos of 3x. So here if we try to replace d square by a square, then we get the value of denominator as 0. So to avoid the 0 value in the denominator, so apply possibility number 2. So that means when we get 0 in the denominator, attach x on numerator and take the derivative of denominator with respect to d. So if we attach x on numerator, then we get this as x upon 6. Derivative of d square plus 9 is 2d into sin of 3x minus cos of 3x, which is equal to x upon 6 to the 12. Then we know that 1 upon d, whenever 1 upon single d term is available in the denominator, so then its meaning is integration of x dx. So if we apply this formula, then we get this as x upon 12, then integration of sin of 3x dx minus integration of cos of 3x dx. So if we take the integration of sin of 3x and cos of 3x, then we get the value for particular integral as minus x upon 36 cos of 3x plus sin of 3x. So this is equation B. In this way we can easily find the value of particular integral. So here from equation A and B we get the value of complete solution, which is the combination of complementary function and particular integral. So that's why so here the complete solution is y equal to c1 e raised to 3x plus c2 cos of 3x plus c3 sin of 3x plus particular integral minus x upon 36 into bracket cos of 3x plus sin of 3x. So this is the second example, which is based on type number 2. Now we can solve this example with the help of alternative method. So in this method we factorize the denominator term so that we can easily replace d square by a square. So whenever d cube term is there, so factorize the term so that we can replace d square by a square with minus sign. So now here one alternative method is there. So now this is the alternative method. So instead of making factor in the denominator, so we can write the term d cube as d square into d. So that is the difference between previous method and this method. So replace d cube by d square into d. So we get the value as d cube minus 3d square plus 9d minus 27 into cos of 3x equal to 1 upon d cube means d square into d minus remaining term as it is. So now here we get d square term. So now according to the standard formula type number 2, replace d square by a square with minus sign. Then we get first term as 3 square, which is 9 minus sign into d minus 3 into 3 square 9 minus sign plus 9. So we only replace d square by a square, so keep the term d as it is, so 9d as it is minus 27. So if we try to simplify the denominator term, then the value of denominator term becomes 0. So we know that this is our possibility number 2. Whenever we get the value of denominator as 0, then attach x on numerator and take the derivative of denominator. So here x upon derivative of d cube minus 3d square plus 9d minus 27 is 3d square minus 6d plus 9. So once again, if we apply formula type number 2, then replace d square by a square with minus sign, then we get this value as x upon 3 a square is 9 minus sign minus 6d as it is plus 9 into cos of 3x. So if we simplify this equation, then we get step as x upon minus 6d minus 80. So for our simplicity, if we take minus sign common, then we get next step as x upon 6 is also common, d plus 3 into cos of 3x. So here we get a single d term in the denominator. That means we get the factor d plus a, so which is our possibility number 3. So now to get d square term in the denominator, so that we can apply type number 2 for replacing d square by a square with minus sign. So let's rationalize the term. So why we are rationalizing this term? So to get d square term in the denominator. So in denominator available factor is d plus 3. For rationalizing this term, so multiply and divide by d minus 3, so that after simplification we get the value as minus x upon 6 d minus 3. Again after applying the formula a plus b and a minus b is equal to a square minus b square, we get the value of denominator as d square minus 9. So once again replace d square by a square with minus sign, we get value as minus x upon 6, numerator value as it is d minus 3, so denominator is minus 9 minus 9. So in this way we can remove the we can remove the term d from the denominator. Now the value of denominator is 108, whereas in numerator we get the value as x into d minus 3. So now to remove the d term from numerator, take cos of 3x to the numerator. So x into derivative of cos of 3x, that means we get this as minus 3 sine of 3x. That means we get answer as minus 3x sine of 3x minus 3 into cos of 3x, that means x as it is, so minus 3x cos of 3x upon 108. So final value for particular integral is minus x upon 36 into sine of 3x plus cos of 3x. So that means there are two ways for finding the value of particular integral. First thing is that whenever we get cubic term in the denominator, so we may use the factor for simplification, or a second step or second method is that, so we can write d cube as d square into d, and we can solve the example. But in both the way, so you will get the final answer as same, or you will get the same answer for the value of particular integral, so which may not be differ. So now if we combine these two solutions together, then we get the value of complete solution, which is given here. Now to understand this type number 2 clearly, take the third example. So now here linear differential equation is d cube plus d into y equal to cos of x. So for complementary function, auxiliary equation is d cube plus d. So if we take the term d common, then we get this as d into d square plus 1. So if we try to solve this equation, then we get the root of this equation as d equal to I 0, I and minus I. So these roots are complex. So as roots are complex, then complementary function is c1 plus c2 cos of x plus c3 sine of x. So in this way we can get the value of complementary function. Now let's find the value of particular integral. So whenever we find the value of particular integral, so write the value of right hand side term. So right hand side term is cos x. So this equation is of the type capital X is equal to cos of ax. So then value of a is 1. Then again if we apply the formula for a particular integral, that means if we try to replace d square by a square with minus sign, then write down 1 upon f of d, which is d cube plus d into cos x. Now here the first term is d cube, so we may apply the factorization concept which is available in complementary function. So we can write this as d into d square plus 1, so that we get d square term and we can apply the formula. So now first term is d, and in bracket we get d square plus 1. So now to get d square as the first term, so rationalize this. So we are rationalizing this term because after rationalization we get d into d as d square. So after rationalizing we get the value of denominator as d square into bracket d square plus 1 into d cos of x. Then if we replace d square by a square with minus sign, then we get the value of d square as minus 1 because 1 square is 1. But if we replace d square by a square with minus sign for bracketed term, then we get the value as 0. So to avoid 0 term in the denominator, so keep the term d square plus 1 as it is. Then for avoiding 0 term in the denominator, so attach x on numerator and take the derivative of denominator, so which is our possibility number 2. So we can write this as x upon minus 1 into derivative of d square plus 1 as 2d into d cos x. so don't cancel the term dd. So here so that is not the way to cancel the term dd. So now here we get the value of derivative of cos x as minus sin x. So again 1 upon d into x is equal to integration of x dx. So finally we get the value as x upon minus 2 into cos x. So this is technically we can find the derivative and then operate the term 1 upon d into x dx. So we get the value of complete solution of this equation, which is the combination of complementary function and particular integral. So here once again try to understand that for finding the value of particular integral, so we factorize the denominator term because denominator is d cube. So second method for solving the same value of particular integral, so instead of factorization, so we may apply different method. So in denominator single d term is available, so apply the concept 1 upon d into x equal to integration of x first. So previously we rationalized that term to get d square term. So instead of rationalizing the term, so we may remove d term from denominator by applying the concept 1 upon d into x, which is equal to integration of x dx. So after applying this concept, we get answer as 1 upon d square plus 1 into integration of cos is sin x. So if we replace d square by minus a square, then we get the value of denominator as 0. So to avoid the 0 in the denominator, that means this is our possibility number 2. Attach x on numerator and take the derivative of denominator. So derivative of d square plus 1 is 2d. So once again here we get the value as 1 upon d. Whenever 1 upon d term is present in the denominator, so we can write this as integration of x dx. So if we apply this formula, then we get the final value for particular integral as minus x upon 2 cos x. So which is our equation number b. So again if we combine the equation number 1 and 2, we get the complete solution of equation. So that means there are two different methods for finding the value of particular integral when we get the d cube term in the denominator. So when we get d cube term in the denominator, we may apply the factorization concept, or we may write the d cube as d square into d. So then let's take the next fourth example, which is the last example of this presentation. So now here linear differential equation is d cube plus d square plus d plus 1 into y equal to cos square x. So for finding the value of complementary function, auxiliary equation is d cube plus d square plus d plus 1 equal to 0. So we know that this is cubic equation, and for solving such type of cubic equation, we are applying the synthetic division method. So if we try to apply the synthetic division method, then here first write down the equation in decreasing power of d, which is already available. Then write down the coefficient of cubic equation, which is 1, 1, 1 and 1. So now here minus 1 is the factor of this synthetic division, because sum of alternative coefficients are equal, because sum of 1 and 1 and again sum of 1 and 1 alternative coefficient is 2, which is equal. That's why d equal to minus 1 is the factor. So keep first term as it is, 1 as it is, 1 into minus 1 we get value as minus 1. So sum of 1 and minus 1 is 0. Again 0 into minus 1 we get answer as 0. Again sum of 1 and 0 is 1. Again product of 1 and minus 1 is minus 1. So we get remainder as 0. When we get remainder as 0, that means d equal to minus 1 is the factor. So for getting factor, so write down this as d plus 1 into d square plus 1 equal to 0. So we get the value of term d as d equal to minus 1 and plus minus I. So these roots are complex, so we get the value of complementary function as c1 e raised to minus x plus c2 cos x plus c3 sin x, which is equation number A, which is called as complementary function. So now let's find out the value of particular integral. So whenever we try to find the value of particular integral, write the value of right hand side. So here the value of right hand side term is cos square x. So this equation is not in your standard form, because a standard form is either sine of ax or cos of ax. Now to get equation in terms of standard form, so we may apply the basic results for converting this equation in terms of standard form. So we can write cos square x is equal to 1 plus cos of 2x upon 2. So after taking 1 upon 2 common, first term is 1 into cos of 2x. But 1 is not in our standard form, so we can write 1 as e raised to 0x. So now we get this equation in the standard form. That means type number 1 e raised to ax, and cos of 2x means cos of ax. So we get two types for solving this example, so which is of the form e raised to ax and cos of ax. Now to solve this example for finding the value of particular integral, so particular integral is mentioned as 1 upon d cube plus d square plus d plus 1 in bracket value of cos square x, which is 1 plus cos of 2x upon 2, so which is equal to 1 upon 2. So if we split this value in terms of e raised to 0x and cos of 2x, so after taking 1 upon 2 as common, then we get the value as 1 upon 2 in bracket 1 upon d cube plus d square plus d plus 1 into e raised to 0x, plus second term is 1 upon d cube. We can write this as d square into d, because in second term we are replacing d square by a square with minus sign, plus d square plus d plus 1 into cos of 2x. So now according to the first type formula for exponential function, whenever capital X is e raised to ax, we are replacing d by a. For the first term, value of a is 0. So if we replace d by a, which is 0, so then we get this as 0 cube plus 0 square plus 0 plus 1, plus in second term is of the type number 2, which is cos of ax, value of a is 2. Now replace d square by minus a square, that means a square with minus sign, then we get the value of denominator as d square as 2 square, which is 4 minus sign d, plus again d square means 2 square minus sign plus d plus 1 as it is. So here the formula which is applied, answer is or reason is given. So then if we simplify the first term, then we get answer as 1, that means 1 upon 2 in bracket 1, plus in denominator for the second term we get value as 1 upon minus 3d minus 3 into cos of 2x. So for our simplicity we may take minus sign common from second term, but in second term we get single d term in the denominator, and according to the standard formula we cannot replace d by a square with minus sign, so we require d square term in the denominator. So to get d square in the denominator, let's rationalize the term for second term. So rationalization means multiply and divide by d minus 1. So after multiplying and divide by d minus 1 term, we get the value as 1 upon 2 in bracket first term 1 as it is, plus minus 1 into d minus 1, 3 d square minus 1 into cos of 2x. So again if we apply the formula for d square by a square with minus sign, so we get the value of denominator as 15. So again if we multiply d minus 1 by cos of 2x, then we get the final value for particular integral as 1 upon 2 in bracket 1 plus minus 2 sine of 2x minus cos of 2x upon 15, which is our equation number B. So from equation A and B, that means complete solution is the sum of complementary function and particular integral, we get the value of complete solution, which is also called as general solution, and its value is y is equal to c1 e raised to x plus c2 cos x plus c3 sin x plus particular integral 1 upon 2 bracket 1 plus minus 2 sin 2x minus cos 2x upon 50. So in this way we can easily solve the example which is based on type number 2, when the right hand side of linear differential equation with constant coefficient is trigonometric term, that means either sine of ax or cos of ax. So now to test your knowledge or for your practice purpose, so here exercise is given, so try to solve this example on your level best, and here along with this example answers are also given. So solve the example and verify your answer with the answer provided on this slide. So thanks student for your patience. So thanks for listening this video carefully. So thanks to one and all.